Hi students, Santosh here. Today I am going to deliver my lecture number 3rd on irrigation engineering and which deals with the water requirement of the crops and various examples on duty, delta, gross command area, culturable command area, etc. And these analytical examples might be useful for you for degree and diploma level examinations, as well as it is very useful for competitive type of examinations such as Maharashtra Public Service Commission, Maharashtra Engineering Services, as well as GATE, IS, and all other type of examinations. So let us start the subject irrigation engineering and my lecture number 3rd on analytical examples. The first problem is calculate the delta for Kharif Jawar having duty of 2500 hectare per cumex. You must know that the duty is measured in area per cumex and delta is the depth of water in meter or centimeter. So we know the relationship between duty and delta. Duty is equal to 8.64 B upon delta, or delta is equal to 8.64 B upon D, where B is equal to base period in days. What is the base period for Kharif? As per table in Maharashtra, we know that the base period for Kharif is 123 days. By using the relation delta is equal to 8.64 B upon D. So 8.64 multiplied by B is the base period, and Jawar is for Kharif period. We consider that Kharif Jawar. So multiplied by 123 and divided by D, that D is duty, that is 2500 hectare per cumex. So you will get an answer in meter because discharge is in cumex, means meter cube per second. So answer is in meter. That answer is 0.416 meter. So we have to convert it into centimeter by multiplying it by 100, that is 41.6 centimeter. So duty delta for Kharif Jawar having a duty of 2500 hectare per cumex is 41.6 centimeter. This is the first numerical based on that relationship, and it is very important for the civil engineering students. The second example is a irrigation canal has a gross commandable area, that is GCA, of 80,000 hectares, out of which 85% is culturable area. The intensity of irrigation for Kharif season is 30% and for Rabi season it is 60%. Find the discharge required at the head of canal if the duty at its head is 800 hectare per cumex for Kharif season and 1700 hectare per cumex for Rabi season. So first of all, the GCA is given, that is 80,000 hectares, and out of which 85% is the culturable area, means the culturable area is 85% of that 80,000, and 0.85 multiplied by that 80,000, we will get the 68,000 hectares as a cultivable area. Out of that cultivable area, the 30% is for Kharif season. So 30% of 68,000 is 20,400 hectares, and for Rabi season it is 60%. So 68,000 multiplied by 0.60, that is 40,800 hectares. So we have to calculate the area under Kharif and area under Rabi by above expressions. Then discharge, you must remember this relationship. Discharge into duty is equal to area, or discharge is equal to area divided by duty. So discharge required for Kharif is, area for Kharif is 20,400 and divided by duty. The duty for Kharif is given as 800 hectare per cumex. So discharge required is 25.5 cumex, because that duty at its head is given as 800 hectare per cumex for Kharif, and for Rabi it is given as 1700 hectare per cumex. So for Rabi season or for discharge in Rabi, the area for the Rabi season is 40,800. So 40,800 divided by 1,700, that is duty for Rabi season. You get the answer 24 cumex or 24 meter cube per second. So water requirement for the Kharif is more than that of Rabi season, because Rabi season the discharge is 24 cumex and for Kharif it is 25.5 cumex. So we design the canal for the higher discharge. So the water requirement in the Kharif is more than that of Rabi season. Hence the canal must be designed to carry the maximum discharge of 25.5 meter cube per second or 25.5 cumex. So this is the way to solve the problem. So you must know these type of problems and you solve analytically also. The third problem is a main canal irrigates the following crops. Calculate the duty. The problem is calculation of duty. Calculate the duty of each crop at the head of main canal. Okay. So the name of crop is jawar in Kharif season. Second, wheat in Rabi season. Third, sugarcane. It is perennial, you know that. Then vegetable, hot weather, and groundnut, hot weather. And delta is given as 45 centimeter for jawar Kharif. For wheat Rabi it is 30 centimeter. For sugarcane it is 180 centimeter. For vegetable hot weather it is 50 centimeter. And for groundnut hot weather it is 30 centimeter. And transit losses are given for jawar Kharif 20%, wheat Rabi 40%, sugarcane 40%, vegetable 40% and groundnut 40%. So first of all, you must know the base period for all these crops. For jawar Kharif you know that base period is 123 days. For wheat Rabi the base period is 120 days. For sugarcane we know that it is perennial, so base period is 360 days. For vegetable hot weather it is 120 days, and for groundnut it is also hot weather 120 days base period. So the irrigation canal has been done in the field away from the head of main canal. It is quite but natural, because irrigation is away from the head of main canal. So there are some certain times of losses. So 1 cumex of water released from the head of main canal will be actually 0.8 meter cube per second or even less due to losses. Hence the duty of water at the head of canal worked out considering the losses. So for the jawar, first duty of jawar, we have to calculate that. So using the relationship, duty is equal to 8.64 B upon delta. So 8.64 multiplied by 123 is base period divided by delta. The delta for the first crop is given as 45 centimeter. So that 45 centimeter is converted into meter, that is 0.45 meter. So the duty is 2361.6 hectare per cumex. But there are the transit losses of 20% for first case. So that 20% we have to reduce that duty. So the duty is 2361.6 into 80 divided by 100, because useful is 80%, because transit losses are 20%. So according to that, the duty is calculated at the head of the main canal is 1889.28 hectare per cumex. Similarly, duty of all other crops are worked out using the relationship 8.64 B upon delta. And please remember, if the transit losses are 40%, then available or useful duty we have to calculate it as a 60%. When transit losses are 50%, then for duty calculation we have to consider the 50%. So 50 and 50 both total is 100. If transit losses are 80%, we have to multiply it by 20% or 0.20. Accordingly, by using the relation duty is equal to 8.64 B upon delta, or delta is equal to 8.64 B upon duty, we have to calculate the other or unknown terms. But you must remember that the duty in hectare per cumex, and that B is equal to base period is number of days, and delta, that is depth of water in centimeter required to come the crop at maturity, it is in meter. So we have to convert it into centimeter. Then we are going to discuss the fourth type of problem. That fourth type of problem is based upon the area. The culturable irrigation area is given as 80% of the gross area. Intensity of irrigation, that is II, is given as 50% of Rabi, and II given for the 25% for the Kharif. And average duty at the head of the distributary is 2000 hectare cumex for Rabi, and average duty at the head of distributary is 900 hectare per cumex for Kharif, and we have to calculate the discharge. So it is very simple problem. If gross culturable area is given as 80,000, gross culturable area, we assume it as a 80,000 hectare, then total irrigable area is 80% of the GCA, which is given in this problem. So 80% of 80,000 is 64,000 hectares. Then total area under the Kharif. So total area under the Kharif is 25% of that. So 25% of the 64,000 works out to be 16,000 hectare. Total area under Rabi is given as 50%. So 50% of total area under Kharif. Total area under the Kharif is 25%, not 50%. So 25% of 64,000, it is 16,000 hectare, and for Rabi that is 50%. So 50 divided by 100 into 64,000, that is 32,000. That is half of total irrigable area is under Rabi. So discharge required for Kharif season 60,000 hectare divided by 900, that is duty, that is 900 hectare per cumex. You will get the discharge as a 17.17 cumex, and for Rabi, the area is 32,000, and divided by average duty that given is 2000 hectares per cumex for Rabi, you will get the discharge as a 16 cumex. So design discharge should be the maximum of that Kharif and Rabi. So maximum is 17.77 cumex. So design discharge is 17.77 cumex. That is the answer. So you must remember, or you must remember this relationship between discharge, area, duty and delta relationship. And also you must know the gross culturable area and then intensity of irrigation, and that formula might be useful for solving you the analytical problems. So let us start the last problem on this water requirement of the crop, and that is water is released at a rate of 10 cumex from the head of sluice if the duty at the field is 750 hectare per cumex and the loss of water transit is 30%. Find the area that can be irrigated. Here area is asked. So given is Q, that is 10 meter cube per second. Given are the transit losses, that are 30%. So the design discharge at the head of the field is reduced by 30%, means useful is 70%. So 10 multiplied by 70 divided by 100 is 7 cumex. So duty is given also. Duty at the field is 750 hectare per cumex. So area irrigated is equal to duty multiplied by discharge. That is also a relationship. So area irrigated is 750 multiplied by 7, that is 5250 hectares. It is so simple, but you must know how to calculate the losses, how to calculate the useful discharge or useful duty at the head of the canal. You must know how to calculate the base period. The base period always in number of days, and duty always in hectare per cumex, and the discharge is in meter cube per second, and delta is calculated in centimeter, but by that relationship it is in meter. So you must know all the given terminologies, their units, and you must know the relationship between the duty and delta, and also area, discharge and duty, to calculate the answers of these analytical questions. So this is over for this lecture, but you must know such a type of problems must be asked in analytical examinations. So again, I am requesting you to subscribe my channel for MPSC mains as well as diploma and degree level students, and please subscribe me for getting more and more idea cleared about the civil engineering. Till then,